This naturalrefrigerants.com article is being read by an automated voice. High temperature CO2 heat pump team is runner-up in New York's Empire Technology Prize. By Michael Gary. Published September 23, 2025. A group of companies that has develops, manufactures, and installs high-temperature CO2-based heat pumps for a range of commercial applications was named runner-up in the New York's Empire Technology Prize competition at a ceremony in New York City on September 19th. The companies, Flow Environmental Systems, Ambient Enterprises, and Gilbar Industries, received $100,000 as the second-place winner. The CO2 heat pump is manufactured by Minnesota-based Flow Environmental Systems. New York City-based Gilbar, a business unit of Ambient, is a manufacturer's rep that designs, installs, and services building HVAC systems. The companies also collaborated with efficiency experts ecosystem. It's a great honor to be part of advancing the industry with high-temperature heat pumps, especially one using a natural refrigerant, said Sean Jarvie, Chief Technology Officer for Flow Environmental Systems. Flow's CO2 heat pump can be the best technical and economical solution, in addition to being ultra-low GWP and PFAS-free, he added. Flow's CO2 heat pump is capable of heating water to 180 degrees Fahrenheit, 82 degrees Celsius, for space heating, and can also provide domestic hot water and cooling, and can use air or water as a heat source. It has a capacity range of 20 to 120 TR, 70.3 to 422 kilowatts per module, and operates down to minus 40 degrees Celsius, minus 40 degrees Fahrenheit. With a 3.5 COP, said Jarvie. The hot water heat pump is well suited for the many high-rise apartment buildings in New York City with baseboard radiators, said Nick Denson, sales engineer for Gilbar, a manufacturer's representative. The system is also applicable to office buildings, hospitals, industrial uses, and district heating. The grand prize winner of $1 million was Miller Proctor Nicholas, a manufacturer of steam and hot water heat pumps that use R515B and HFO1233ZD refrigerants. In addition, Johnson Controls received honorable mention for high-temperature heat pumps that use HFO1234ZE and water. R515B has a 100-year GWP, 4th IPCC, of 293. It consists of 91% HFO, 1234ZE, and 9% HFC227EA, both of which convert to trifluoroacetic acid, TFA, in the atmosphere, the former at less than 10%, the latter at 100%. About 2% of HFO 1233ZDD converts to TFA. 4 other companies were finalists, including 2 that employ natural refrigerants, Clean Heat Technologies, which makes CO2-based steam heat pumps, and Enerin, which produces steam and hot water heat pumps that use helium as a refrigerant. The other 2 finalists were Atmos Zero, which supplies steam heat pumps with HFO 1234ZE and HFO 1233ZD, and the combination of Hydronic Shell Technologies and Cycle Retrotech, which offer modular overclad window facades for retrofits of apartment buildings that facilitate the distribution of heating and cooling. The Empire Technology Prize competition, announced in 2023, was designed to advance building technologies for low-carbon heating system retrofits and save energy and costs in tall commercial and multifamily buildings in New York State. It was supported by the New York State Energy Research and Development Authority, NYSERDA, and Wells Fargo, and administered by the Clean Fight, with technical support from the Rocky Mountain Institute. The 7 finalists were announced last year. New York State is investing in modern, energy-efficient solutions to help manage energy costs and reduce demand on the electric grid while putting New Yorkers' health front and center, said New York Governor Kathy Hochul. Participants in this competition have the vision and dedication to advance new and innovative technologies that will help provide modern amenities in our aging building stock and improve the quality of life for residents across the state. Union Theological Seminary installation. The award announcement noted that Flow's CO2 heat pump will be installed as a demonstration project at the Union Theological Seminary in Manhattan, enabling the first carbon dioxide high-temperature hot water heat pump deployment in New York. Multiple 20 TR flow modules will simultaneously supply hot water for space heating and domestic hot water, as well as chilled water and dehumidification for the Union Theological Seminary, including precise temperatures for precious scriptures in the building, said Lucas Taub, project development engineer for Ecosystem. Flow said it expects to minimize retrofit costs while using the existing infrastructure. As one of the 7 original finalists, the group received $1.2 million from the prize administrators to support the demonstration project. They were also given an initial $250,000 award with the potential for up to an additional $750,000 as they achieved milestones in advancing their system. In the past year, a number of commercial CO2 heat pumps designed to produce domestic hot water, but not space heating, have been introduced in the U.S. These CO2 heat pump water heaters are designed for domestic hot water but not space heating because of the high delta T or temperature differential required between the outlet and return water supply. Flow's CO2 heat pump, which supplies both space and domestic hot water, is able to overcome that challenge through the manipulation of flash gas, said Jarvie, who dubbed this the system's secret sauce. Other deployments? In addition to its planned deployment at the Union Theological Seminary, Flow's heat pump have been or are being installed in a wide range of applications in the U.S., noted Navade Burney, Chief Financial Officer for Flow. These include water source installations at a Union Hall in Minnesota and an airport in Fargo, North Dakota, and planned deployments at California tech companies. Flow will soon complete an installation at Stauss Family Creamery, a California company producing organic ice cream, yogurt, and other dairy products. The heat pump will be used for hot water pasteurization, cooling of dairy products, and freezing of ice cream. In addition, a new CO2 energy storage unit designed to cut the creamery's energy costs will be deployed. CO2 will be cooled during off-peak hours and used during peak hours, cutting peak electricity costs by 85%, said Burney. In an interview last year, Jarvie touted the resilience and flexibility of Flow's CO2 heat pump. With an air interface, we can use an adiabatic cooler to support CO2 heat pump operation in scorching temperatures, he said. We can also handle low ambient temperatures that no other heat pump on the market today can touch,